Hi, Claymore. Claymore, you gonna help me? Say hello to General Chemistry, Claymore. Claymore really likes paper, but Claymore's going to have to leave now. Bye-bye, Claymore. Bye-bye. You gotta move. You gotta move. You really have to move. So today we're gonna talk about the activity series. You can write any reaction you want, but knowing whether or not it's going to proceed is dictated by something called the activity series. Okay, so that's what we're talking about today, the activity series. Claymore, you're shading the paper. Scoot over. Come on, get down. Okay. So we can write, stop at the tail. You can write any reaction you like. Remember, we're using RxN for reaction. But it may not necessarily proceed. As you have written it. That's where the activity series comes in. So we have the activity series. We can write any reaction we want, but it may not proceed as written. And this lovely little piece of paper called the activity series is how you tell. Yeah, thank you. So there are two activity series. This is on page 286 of your textbook, and you're going to be using it quite a bit. There are two activity series here. One is the activity series of metals and hydrogen. Hydrogen's the only non-metal on here. And the other is the activity series of the halogens. Okay, so one activity series is quite long. The other activity series only has 4 elements in it. The elements at the top of the activity series are more reactive or active than ones at the bottom. And the activity series in your book is nice because it is broken down into 1, 2, 3, 4, 5 sections. So how the activity series works, and I'll give you examples, is any element which is shown alone can replace any element below it from a compound. This only works for single replacement reactions. Okay, so it's only good for single replacement reactions. Won't help you out for double replacement reactions, only single replacement. Those have the form AB, A plus BC gives you a C plus B, if you remember, where a metal replaces a metal, or a halogen can actually replace another halogen. So back to the activity series itself. Okay, so we have the two series, and this first group of metals, from lithium to sodium, are very, very reactive. If you put them in water, they react vigorously. They give off lots of hydrogen gas. Some of them, like potassium or rubidium, even ignite in the water, and you've got a nice explosion, pretty colored flame. Okay, and it says that these elements here, this group, will react with cold water. They'll also react with hot water. They will react with acids, and they will react with oxygen. Now, if you go down to this next section, from magnesium to cadmium, they're not as reactive as the first group. They will react with hot water or steam. They'll also react with acid. They'll also react with oxygen. This next group, from cobalt to lead, do not react with water at all. They will react with acids. They will react with oxygen. The next group, from hydrogen down to mercury, react with oxygen. They're not going to react with acid, hot water, cold water, or steam. And then the very last group, silver, platinum, and gold, are fairly unreactive. They will form oxides or tarnish, as it were, with great difficulty. The halogens we just rank in terms of how they react with one another. We're going to see how this works in a bit.